My name is Ashish Kumar. I'm an assistant professor, Department of Computer Science Engineering, Garg, Engineering College, Ghaziabad. My subject is operating system and subject code is BCS 401. Today my topic is CPU scheduling. In that CPU scheduling, I have to discuss about the scheduling concept, performance criteria, process concept of process state, process transition diagram, scheduler, scheduling algorithm, multiprocessor scheduling. First, scheduling concept. What is the scheduling? Before move on this slide, I have to discuss scheduling. Basically, create a schedule of any jobs. Suppose 2, 3, 4 jobs are there. I have to just generalized. I have to create a schedule. First job first inserted, second, third, fourth. In this way, I have to generate the scheduling. So in that case, efficiency increases and job increase fasterly in this way. So in this slide already discussed, scheduling means process work is done to finish the work on time. That means job schedule in that way कि one job initialize and completion stage. CPU scheduling is a process that allowed one process to use the CPU while another process is delayed instant due to unavailability of any resource such as input or etc, thus making full use of the CPU. CPU scheduling, that means a process basically executed and unavailability of resources, that means move on the input output devices, input output sections, and CPU are that times ideal states. So through the CPU scheduling, idealness of CPU decrease and utilization of CPU are increases through the CPU scheduling work. The purpose of CPU scheduling is to make the system more efficient, faster and fairer. Why do we need the CPU scheduling? In case of multi-programming, multi-processing, maximum number of utilization of the CPU and no overhead, in that cases CPU scheduling is more needed. So here 5 points are 5 points are mentioned. In multi-programming, if the long-term scheduler picks more input output bound process, then most of the time the CPU remain ideal. The task of operating system is to optimize the utilization of resources. If most of the running process change their state from running to waiting, there may always be a possibility of deadlock in the system. To reduce this overhead, the OS need to schedule the jobs to get optimal utilization of CPU and to avoid the possibility of the deadlock. So through in this slide, basically I know that why need a CPU scheduling. First, in case of multi-programming, long-term schedulers in more number of input output needs. So in that cases, CPU in ideal state. That means CPU remain in ideal form. So CPU utilization is decreases. And another point I have to discuss, the operating system to optimize the utilization of resources. Next, a running process changes their state from running waiting to there always be a possibility to deadlock, because a running process cover the resources, another process is waiting state. In that case, most of time create a deadlock condition. So in that, every values are decreases through the CPU scheduling process. Purpose of scheduling. So purpose of scheduling. Why use the scheduling? First, your mind always why you use the scheduling. First, maximum CPU utilization, because if CPU not moving on ideal state, so utilization of CPU are increases. Because in case of scheduling, you have to provide, you have to schedule ki in that jobs, another jobs in lineup. If in that job move on the input output, then another job in move on the CPU. So utilization increases. Fair allocation of CPU. Through scheduling, before I have to decide which processes are running first, another process, which process are running second. So fair allocation of the CPU, maximum throughput. If utilization of CPU is increases, so maximum throughputs are increased. Minimum turnaround time. turnaround time, that means it is called the hold time. Arrival time minus completion time minus arrival time, it is the turnaround time. Minimum waiting time, that means if you use the scheduling, so waiting time is minimized. If waiting time is minimized, then CPU utilization is high. Minimum response time is fast in case of types of scheduling algorithm. Some most of scheduling algorithm are there given. So here some scheduling are mentioned here. First come first serve. That means number of processes are there. If one process first come and that is executed. If another process come, then it is executed. It is also called the non-primitive type of scheduling. In case of round robin case, you have to provide the some quantum value or quantum time of any process. If quantum time is 2, 3, 4, any given. So a process if enter any CPU, so its execution time is 2 minutes, 3 minutes, 4 minutes. It is given already in a conditions way. Shortest job first. In case of shortest job for scheduling, number of jobs are there, but execution time, that job execution time is minimum. So which type of jobs first insert in a CPU, that is called the shortest job first times. It is also non-primitive, but round robin is the primitive type of scheduling. Next is shortest remaining time first, that is called shortest remaining time, SRTF, shortest remaining time first. That means which job time is less, burst time that means execution time is less, it is work first. Priority based scheduling, if 5 to 6 jobs are there in any execution time, so every job provide the some priority 1, priority 2, priority 3, priority 4. First priority 1 jobs are executed, then another priority jobs are executed. So already I have to discuss, if you move on in office and then you have to decide which job are completed today. So you have to provide the some priority of your jobs. 1, 2, 3, 4. One by one we have to complete that jobs in a whole day sessions. So here also provide the priority based scheduling. CPU scheduling criteria. What is the most time in a university exam asking the question, what is the criteria of CPU scheduling? The first is CPU utilization, throughput, turnaround time, waiting time, response time, completion time. First, CPU utilization is high. The main objective is any CPU scheduling algorithm is to keep the CPU as busy as possible. Throughput is high, turnaround time is low, waiting time is minimized, response time is fast, completion time is minimum. So here mention how to find the completion time, turnaround time, waiting time and response time in completion time in a numerical view. So in waiting, in mention turnaround, already I have to discuss how to find the turnaround time. Turnaround time, that's equal to completion time minus arrival time. If a person enter any place for around 10 o'clock and he execute your own task around completed that task is around, if enter 10, then it is a completed to 12. So it is total turnaround time is 2 hours. Waiting time is there also. Turnaround time minus burst time. Burst time, it is the execution time of any process. Response time means when a CPU meet a process. First time minus arrival time. Completion time, all you know, when your processes are completed, that is called the completion time. Here through the diagram we have to discuss times related process. So here ready, run, complete, arrival times. So CT minus AT is equal to WT minus plus BT. You have also found one by one everything. I here mentioned TAT, that means the turnaround time, BT minus bus time, and AT is the arrival time. Yeah, we have already discussed in that part. Okay. Next, time related process. Time related process, that means whole pictures, whole CPU scheduling environment depends upon your time, because using of time is low or high and utilization time is minimum, increase, waiting time is decrease, increase. Everything is related to your time process. Arrival time, burst time, completion time, turnaround time, waiting time, response time. Already in that points of I have to already discuss in previous slides. Efficiency, importance of CPU utilization, scheduling criteria. First, efficient resource utilization. That means if number of resources is minimum, so resource utilization is very high through the CPU scheduling. Fairness, fairness, that means fairness related to your process move on the CPU. So first, which process are moved first, second, third, and everything. Responsiveness, CPU scheduling algorithm that prioritize response time ensure that process that required immediate attention are executed quickly, improving the overall responsive of the systems. Predictability. CPU scheduling algorithm that prioritize turnaround time provide a predictable execution time for process, which is important for meeting deadlines and ensure that critical tasks are completed on time. Process management. How to process manage first in a OS. Operating, all you know that the operating system basically manage the whole process, which process are enter in a CPU and which process are out from the CPU and which process are replicate, which process are replaced, suspending, deleting, providing mechanisms, all are given in that slides related to the process management. What is process in OS? All of you know that process is a program. Program if enter in a CPU, that is a move on the process form. The execution of process progress in a sequential fashion. A program is a passive entity while a process is an active entity. A process includes much more than just the program code. Process is the unit of work in modern time sharing system. A system has a collection of process. User process always has system process. So a process includes the text section, stack, data section, program counter, register, content, and so on. Process in operating. So what is the process? Process that means ki how to process or enter in a CPU. So in a CPU, it is divided into different parts in a process. First is stack parts, heap parts, data parts, text part. So our running program that serve the foundation for all computational process, essentially running software that you can any process must occur in the specific orders. That is basically it is a orders. Okay. Component of process. First, what is a component? Component, that means how to divide a process to 4 parts. Process basically divided into 4 parts: stack, heap, and text form. Stack temporary data like method of a function parameter, return, address, and local variable are stored in the process stacks. This is the memory that is dynamically allocated to a process during execution time. Execution time में dynamic memory allocation is provided. Process. Text. This comprise the content present in the processor's register as well as the current activity reflected by the value of the program counter. Data. The global as well as the static variable are included in these sections. Process state. That means a process which follow a process from initial to final stage, which are what different step are follows. First step, if processes are created, that is called the new process. If processes move on the running state, that means move on the CPU, that is called the execution state. If processor move on the input output, any input output, that means called the waiting state. The process waiting to assign the processor again, it is called the ready state, and the process is finished, it is called the executions. Terminate. It is a process state diagram. Basically, in a exam point of view, it's the most important. In a most of time, I have to see that the in a university paper, most of time I ask the question, what is the process state, and describe the process state. So in here, so it is a divided different part. It's a main process diagram, Basically, in that diagram, I have to discuss every parts: waiting state, suspended, ready, running, normal. In normal form, basically normal form, process generally process in that form. That means process created, process moving on RAM, and process moving from the RAM to through the running states, and that termination state. This is the 2 to 3 steps that my process are completed. If no create any issue and not create any input output and not create any priority and in different task performance. So it is performed just initiate and finish condition. But in condition process move on any input output request, that is move on the waiting block. Most of process, number of process are increased in waiting a block, that is a process move on the suspended wait. And through the suspended wait, if process are move on waiting blocks, if suspended wait are full, suspended wait memory if full, then process are moving on the suspended ready. Then resume, then create, and then here this whole environment is given here. Scheduler, the process manager activity is the process scheduling, which involves removing the running process from CPU and selecting another process based on a specific strategy. The scheduler purpose is to implement the virtual machine so that each process appear to be running on its own computer to users. The scheduler parts of the. Here mentioned long-term scheduler. In general way, through this figure, I have to say that. A process new to ready, it is called a long term. Ready to running, it is called a short term. And running to waiting, it is called middle term. Ready to suspended, it is all this called middle term. But long term, if process moving from new to ready state, and short term ready to running state. So basically here just a summary of given long term schedulers. The job scheduler is another name of long term scheduler. It selected process from the pool and then maintain them in the primary memory ready queue. The multi-programming ready mostly controlled by the long term scheduler. The goal of the long term scheduler is selected the best mix IO and CPU bound process from the pool of jobs. If the job scheduler select more IO bound process, all the job may become stuck. The CPU will be ideal for the majority of the time. A multi-programming will reduce to just a summary, nothing else. Again, same as short-term scheduler. Short-term scheduler. CPU schedule is another name for the short-term scheduler. It is choose one job from the ready queue and then send the. So that is a just to define the process. Same as medium-term scheduler. Next is in an exam point of view, most of time 2 number questions ask the question user level thread, user level and thread and kernel level thread. What is the user level thread and kernel level threads? User level threads are faster to create and manage because all are managed through user, not any interference. But in kernel level thread are slower to create and manage because system software are involved in a kernel level. Second point. Implementation is by a thread library at the user level. Operating systems support creation of kernel level threads. User level thread is generic and can run on any operating systems. Kernel level thread is specific to the operating system. Multi-threaded application cannot take advantage of multiprocessing, and kernel routine themselves can be multi-threaded. So you have to read in these differences is a major. And another difference is process and threads. All you know that thread is a part of the process. Process basically heavyweight of resource intensive, and thread is lightweight, taking lesser resources than a process. Process switching need to interaction with operating systems. Thread switching does not need to interact with operating systems. In multiple processing environment, each process executes the same code but has its own memory and file resources. All threads can share same set of open files and child process. If one process is blocked, then no other process can execute it until the first process is unblocked. While one thread is blocked and waiting, a second thread in the same task can run. Multiple processes without using thread use more resources. Multiple threads process use fewer resources. In multiprocesses, each process operates independently of the others. On thread can read, write or change another thread's